Alright guys, so today's video is going to be a little different. I haven't even decided if I'm going to publish this yet or not, but I have a friend who purchased a 3D printer for her son, and I volunteered to get it all set up and calibrated. Young boy that is interested in getting into 3D printing, but when you first start out, you don't know what you don't know, and so Boston, this is for you. This is your new 3D printer. This is a Creality Ender 3, just the Ender 3 standard. It's got a pretty good printing capacity. It can use a variety of printing materials, printing filaments, and it's a pretty good starter machine. I have gotten it dialed in and calibrated, and it should be ready to print, but because you're new to this, I wanted to give you kind of some general pointers. This machine originally came with a Marlin firmware, so that's the software that runs on the board inside of this machine, and it was an older version, so I've updated to that new firmware version. It's now on version 2.1. The firmware updates are important to kind of stay on top of, at least occasionally, just because they add in some extra protection as far as if it overheats and it automatically shuts down and things like that. So when you get it, there will already be some filament installed, and what is on here right now is this blue, and this filament is called PLA. So this is a very good, easy to print filament. Usually the best thing to start with. Comes in a variety of colors from a variety of manufacturers. Some of it is better than others, but this so far prints fine. This is a Gizmo Dorks brand. One thing to note, PLA filament will absorb moisture out of the air. So if you've got a spool of filament that you're not going to be using, it's best to keep it in like a Ziploc bag, just so it doesn't absorb a bunch of extra moisture. If too much moisture is absorbed into the filament, when you print, that moisture will actually boil once it goes through the extruder, and it will cause like some bubbles, and it'll make some popping noises. So just something to keep in mind. If you have extra filament, put it in a sealed container. So this specific printer has a nice little control panel over here with a little turn knob that is also a button. Just going over basic parts of the printer. This is your print bed. You've got 3 axes, an X axis, a Y axis, and then a Z axis. So there's a big screw on the back here, and so that screw will turn. There's a motor down here at the bottom, and that screw will turn to make this gantry raise up and down. There are typically 2 different types of extruders that can be found on 3D printers. There's like a direct drive, where you've got an extruder motor directly on the hot end, and it will just pull filament straight into the extruder and force it through the hot end. The kind that's on this machine, I don't remember the exact name of it, but it uses what's called a Bowden tube. So it's a super slick tube that the filament will actually go through, and then your extruder motor is mounted on the back of this upright post, and it basically pushes the filament through. Of course, your filament spool mounts up here, and you'll route it down and into the extruder. How this works is it will heat up a nozzle in here to about 200 degrees Celsius, and it forces the filament through that hot nozzle and basically melts the plastic and then draws it out on the print bed. Because you are fairly young, just some things to keep in mind. The print bed on this is a heated bed. The bed heater helps keep the print stuck down to the bed while it's printing. The bed temperatures are usually between 40 and 60 degrees Celsius, so about 120 degrees Fahrenheit. So think of some hot water in the shower. It's about that temperature that this bed gets to. The tip underneath this hot end will get much hotter. For PLA, your temperatures are usually anywhere from about 180 degrees Celsius up to 215, and then some of the other materials actually print hotter than that. So something to keep in mind, never put anything on here that could potentially catch fire. It wouldn't necessarily catch fire here, but if this nozzle under here touched it, if it was left on there long enough, could potentially catch fire. On the side over here, there will be a red switch. You've got a cord that comes in, and this just plugs into the side side of the power supply here and then plugs into the wall. When you turn the switch on, the display will light up and we'll see some options. So you can see the display comes up, it displays which firmware version you're using, and then you've got some information about the printer. So you've got, this is an Ender 3. This little symbol here indicates the nozzle, and it's currently at 22 degrees Celsius. This is the bed temperature. That flat plate is your print bed here, and it is also currently at 22 degrees Celsius. So that's just ambient temperature of the room I'm in. Over here, this is a little fan icon, and you can hear the noise running. And that is the fan that is directly in here. And so it's got a pretty good guard on it that you can't get your fingers in, but just don't stick anything in there. This fan will run anytime this printer is powered on. So it's kind of noisy, but this fan is plugged directly into a power port that as soon as the switch turns on, this fan comes on. There's another fan on the side here, and this fan will be used when you're actually printing. It blows some air down underneath this nozzle and helps cool the plastic that's coming out of the end of the nozzle. And so when this fan is running, you'll actually see this little fan icon spinning. So you've got some numbers here. You can see your X, and it currently is changing between a 0 and a question mark because it doesn't really know where the tip of this is yet. You can see the same for the Y and the Z. It doesn't know the position of the nozzle. Here you can see like a little stopwatch type thing. You've got a minutes and seconds, and when you're actually printing, this will change and update to show how long you've been printing. Down here we see Ender 3, and we can see that the version of the control board that is in this is a 4.2.2, and you can see it's in the ready state. If you push this button, you go into the menu. In this menu, you've got several different settings or several different controls. You've got a motion, a temperature, configuration, and you can see about your printer, and then you can see it says no media. We'll come back to that in a bit. So if we click into our motion, we can see we have an option to move the axis. We can auto home, or we can disable the steppers. The steppers are the motors that control the movement of this machine. They're called stepper motors. So if we go to move axis, actually, let's go back. We'll auto home this. So I'll go down, and as soon as I click this button, it'll go into an auto home procedure. And basically what that does is there's a limit switch. So this is a Z limit switch. There's a limit switch up here for your X axis, and then there's one back there for your Y axis. And it'll move until it hits each of those switches, and then it knows that the tip of this nozzle is at the home position, the 0, 0, 0 position. So we'll go back into our menu, and we'll hit auto home. So it goes up a little bit just to make sure that it has some room to travel. And you can see it did just a little bump on the X axis, and here the build plate will go home. And it's moving at a slow speed right now because you don't want to risk crashing that nozzle into anything. So it goes super slow so that it can stop when it needs to. And you just heard that little switch click. And so now we're at the 0, 0, 0 position, and you can see our coordinates have stopped flashing to the question marks because now it knows exactly where it's at. It's at the 0 home position. So now if we go into motion, we can move an axis. And so let's start with our Z just so we get our nozzle away from the bed. So you can move this in increments of 10 millimeters, 1 millimeter, 0.1 millimeter, or you can even go down to a 25 thousandths of a millimeter, which is very tiny. So we'll go to 10 millimeter. So it's going to be a 10 millimeter step. And when I rotate this just one click, it will go plus 10 millimeters. So it should raise this up 10 millimeters. And we'll do another 10 millimeters. And now we're at 30 millimeters. And then if we go the other way, it should go back down. And back down to 10. And we're gonna stop there. So we can tap the button to go back, go to the very top, to the up arrow. And now we can do the same thing. We can move the X-axis, which is this one that goes left to right. So we'll go to a 10 millimeter setting. And now let's do a 0.1 millimeter setting. So see if you can tell how much this moves. It just moves a very, very tiny bit. And anytime you want to go back to the previous menu, you just go to that return arrow and tap the button. You can also move the extruder, and so since I don't have any filament in here yet, I will. Oh, so right now I just tried to move the extruder and it tells me hot end is too cold. So that's just a warning. If we had filament in there, you never want to move the extruder unless this hot end is up to the proper temperature for whatever material you have loaded. But just to show, I'm going to click proceed and I'll do 10 millimeter step. And so when I turn this once, you should see that gold circle there in the middle start to move. Very slow. But if there was filament loaded in there, it would be pushing it through this tube. So I'm going to back out of this. I think that's all we've got in here. So right now, because the steppers are enabled, if I were to try to move this, it won't move at all because the stepper motor is engaged. It's holding this where it is, just so it doesn't move when it's not supposed to. If we go back in to motion and click disable steppers, it will turn those stepper motors off, and now I can push this across, or I can pull this. When you do these, you want to move them slowly. You don't want to force them too quickly. And then I could also, back here, this screw, I could turn this to make the gantry go up and down. So the next thing is going to be temperature. And so if we go into the temperature, we can see that the nozzle is at 0, the bed is at 0, fan speed is 0%. And then we've got a couple of preheat options. So PLA is the kind of filament that we currently have. ABS is another kind of filament. And they have different temperature settings. So if we go into the preheat PLA, and we can either preheat PLA, and that's going to preheat the bed and the nozzle on the extruder, or you can just preheat the hot end or preheat the bed individually, depending on what you're needing to do. So I'm going to go ahead and preheat just the end because I want to get your filament loaded up. So I'm going to click this preheat PLA in, and you can see this top number now is configured to go to 220 degrees Celsius. So you can see our actual temperature is starting to rise. This is our goal temperature, and this is the current temperature on the bottom. So while that's doing that, let me get the filament ready to go. So when you store your filament, you want to make sure you keep it fairly tightly rolled because if this were to get tangled and kind of knotted up on this spool, it's not going to come off of here, and it's going to cause you issues when you're printing. This one, there's usually on these spools, there's some little slots that you can kind of weave the filament through just to keep it from, because if you just let it go, it will kind of spring out of control sometimes. So you can see the end of this is not real straight. It's got like a little tail coming off of it there. In order to load it, we want it to have a nice smooth finish, and it's usually easier if you're able to cut this at a 45-degree angle. And so you could probably use scissors, but if you had like a pair of fingernail clippers or something, it would probably work better. So I'll just put that and cut it so it's got a bit of a point on it, a little bit of an angled cut. And that's just going to make it easier to load into our extruder here. So you want to make sure you position your spool on your spool holder in a manner so that it will line off and go into the extruder in the smoothest way possible. Okay, now on the extruder itself, you've got this little lever here, and there's a spring. That spring, it's pretty stiff, but when you squeeze this together, and you might need to get your mom's help or something for this, but when you squeeze this together, you can see it separates these two wheels. So this is your drive wheel, and this is your tension wheel. And so what you need to do is, through the back side of this, there's a hole that filament will slide through, and you can see how it's coming through there. So once you get the filament slipped through this arm, you have to squeeze this so that it removes tension, and then you have to get it forced into that hole, and then ideally you want to keep this squeezed and keep pushing it through until it goes all the way through this Bowden tube. So this is just kind of finger tight on here, so if you need to, you can unscrew this. There's a little tiny black washer on here, don't lose that. But you can squeeze that and kind of push that out to make sure your filament's coming all the way through. And then you can slide that back on and thread it back in so it's finger tight. I'm going to move this camera a little bit. And so I'm going to squeeze the tension arm over here, and with that squeeze I'm just going to push this through here by hand, and you should see it starting to go through the Bowden tube. And so push it all the way until it gets to the hot end. And so with the hot end up to temperature and the tension arm still squeezed together, you can just keep pushing until you can start to see some filament come out. And now we know that we've got filament all the way to our hot end. So now we can go back to our move, or our motion menu, move axis, and we'll move the extruder. And I'm just going to set it on 10 millimeters. And so you can see the filament is kind of starting to ooze out of here even without me moving it. But when I turn this to 10 millimeters, I think I made it 30 millimeters. And so it's going to push 30 millimeters of plastic out of here. And so that's basically what it does when it's printing. It just pushes plastic out, but the tip of this nozzle is super close to the bed or to the layer that's below it, and it just squeezes plastic out and continues squeezing it out until your print is complete. So you can see with, let me get back out of here. So you can see we're at 220 degrees. And for this particular filament, this brand of filament, 220 degrees is probably a little too much. And I say that because the plastic continues to ooze out of here. When you have a correct temperature, it won't ooze as much, but it'll still be melted enough for it to squeeze it through the hole in the nozzle. But we just wanted to get filament loaded up in here, and we can go on to the next step. So for now, I want to turn the temperature back down. And so if you go into temperature, you can do cool down, and basically it now sets our desired temperature to 0 degrees, and that's Celsius. And you can see it's already starting to cool down. And it's cooling down because this fan is running and drawing some heat away from that. So let that get back down to temperature so we don't burn ourselves on this nozzle, and we'll be good. One thing that is nice about this particular extruder is when you get up close to this nozzle, you can see a little bit of brass sticking out of the end. That's the actual hot part. This actually has a silicone cover on it, so if you get your finger close to it, it's not going to be as likely to burn you. If you hold your finger on it, there's enough heat coming off that it will get warm pretty quickly, but it won't instantly burn you if you get a little too close to it. So I would recommend a pair of long tweezers or something for getting those little pieces of plastic off of there. But it's nice having that silicone cover on. So you can see all these little plastic bits. Anytime you're dealing with 3D printing, you will end up with a lot of these. So it's nice to have a trash can or a cardboard box or something close by. These are cooled down, so they cool to the touch, but just so they don't get mixed up in the carpet and stuff, it's nice to have somewhere that you can throw them in. This particular plastic, PLA, is a somewhat plant-based plastic, so it's not as bad on the environment as some of the other plastics. That's something to be concerned with if we're just creating a bunch of plastic waste. This will biodegrade faster than normal plastics, so that's a a good part about using PLA for this. Okay, so now let's get into actually using your 3D printer. So in order to actually be able to print something, you have to be able to tell the printer what to do. The way to do that is by finding a 3D model that you want to print. You can either find one from various sites, thingiverse.com, Thangs, Thangs.com. There's a variety of other ones. Thangs is one that I just learned about in the past couple days. Thingiverse has been the one that I've used for quite a while. But you can just search for something you want to print and download the model. When you download the model, it's going to be an STL file. And that is basically a 3D model. In order to get that prepared so that you can actually print it, you have to use a software that will slice it into individual layers. So probably one of the most popular out there is called Cura. And so you can just search for Cura, and it's just free software. It is made by the company Ultimaker. There is another slicing software made by Prusa, P-R-U-S-A. I have not tried that one, but it is another option. So just click on Cura's site here, and they recently released version 5 of this. I haven't actually tried version 5, but you can just download it for free, and you choose what operating system you're going to put it on. So if you have a Mac or a Linux or a Windows machine, and so you can see up here it's downloading, and once it downloads, we can just open the installer. And so typical installation, just click next, agree to their terms, choose the default install location, and you can just install it. And we'll let this install and be right back. When Cura opens up, because I already had it, I had an older version installed, it did pull forward my my other 3D printer profile, but yours may actually prompt you, since you've never installed it before, it may prompt you to configure a new machine. If not, you can just go up to Settings, Printer, and Add Printer. And this will be a non-networked printer. And so you can see it starts out with Ultimaker because this is their software, but if you collapse or just scroll down past Ultimaker, for your printer, go to Creality 3D. We'll expand that, and we'll choose the Ender 3. And so if you wanted to name it something specific, you could change the printer name here, and we'll click Add. So someone's already created a profile, kind of basic machine settings, and so this tells you your X width, so the maximum size piece that you could print is 235 millimeters wide, 235 millimeters deep, and 250 millimeters tall. Our build plate is rectangular shaped. We have a heated bed. We're using Marlin. And then this is just the print head settings, just to make sure that the extruder doesn't crash into anything. We have just one extruder, and we'll apply these extruders. Basically, all the default settings are good to go. One thing that I would recommend changing is the start G-code, and I will actually give your mom those settings so that you can set them up on your machine or your installation. So we'll just leave it at this for now. I'll go ahead and hit next. And now we can slice some models. Okay, so here we came to Thingiverse. This is just a website that has 3D models for lots of stuff. I'm going to see if I can find the test print that normally comes with this printer, and it's just called Test Dog. And here it is, the Ender 3 Test Dog. So if we just tap into this, we can see there's a download all files button here. That will download I think that downloads a zip folder, but we really only want the one item. So we can just go to the thing files, and we can see it's called Test Dog STL, and we'll download that. We can then go back to Cura and click our little folder icon or the file menu up here, and we go to our downloads, and there's our Test Dog. And so we open that up, and here we can see it on our print bed. And if you click the model, you can see down here your dimensions here. It's 25 by 25 by 14 and a half. And so that always goes X, Y, Z. And so it's 25 millimeters wide, 25 millimeters deep, and 14 and a half millimeters tall. So the nice thing about STL files is you can resize them to whatever size you want. So with the model selected, you click the scale over here. If you leave it on uniform scaling, it's going to scale everything the same amount, X, Y, and Z. If you were to uncheck this, you could just make it taller and leave it to be real tall and skinny. It may look funny doing that, but we'll just leave it on uniform scaling. And let's say we wanted this 3 inches tall. So 3D printing really makes you think about things in a metric world. 3 inches is roughly 75 millimeters. And so I'll do this a 75 and hit enter. And you'll see that the X and Y sizes will change as well. And it makes our model much bigger. You can click back on the move, and you've got some arrows here. And so if you click on the red arrow, you can just move it left and right. If you click on the up arrow, you can actually lower it down and only print like the dog's head. You can't print it above because it's got to be touching the bed, but you can lower it down. So if you didn't want to print that base, you lower it like that. Or if you just grab the model, you can move it around just about anywhere. If you right click on the model, you can center it on the build plate. You can also multiply it however many times you want, and it'll try to fit them on there. If it can't, it just puts them off to the side over here. So we'll delete those. If you zoom in on this, you can see how most of this is yellow, and that means it's all good. But if you use your if you hold your right mouse button, you can kind of move around it. All of these red areas indicate places that may potentially not print too well because the printer would be printing on nothing. That's called an overhang. And so if there's nothing to support when the printer squeezes the filament out in that spot, it'll just droop down. So sometimes that's desired, sometimes it's not. This particular model is designed to be able to print without any kind of supports, so it'll print just right out of the box. But that's what those red areas indicate. If you had something that came way out over here, there's not going to be anything to support that print. But in the print settings here, you can generate support. So it'll actually print a structure to help support underneath things that wouldn't otherwise have support. After the print is done, you can snap off those support pieces. But this is just kind of a basic print. You do have profiles, and so this shows a standard quality or a dynamic quality, and basically this is either thicker or thinner layers. The thinner the layer, the greater detail and smoother the finish. If you've got thicker layers, it's a little bit rougher of a print, but the actual time it takes to print is much less. So leaving it on standard quality, if we were to slice this, click the slice button down here, it's going to go through and slice this into a bunch of layers. And then we can actually preview. So you can see this particular model in this size, being 75 millimeters tall and roughly 130 millimeters wide. You can see it's going to take 2 hours and 37 minutes. It'll use 23 grams of filament or 7.75 meters of filament. So we can preview this, and here you can kind of see all of the individual layers. Over here on the right, we can see it would be 323 individual layers, and we can drag this top one down and kind of see each layer. If we hold our right mouse button and kind of pan up, we can see it's got this weird like cross-hatching inside. This is called infill. And so most 3D printed parts are not completely solid. There's some hollow areas inside. This uses an infill pattern that will support those layers that will be stacked on top of it, but you don't have to print it completely solid. Typically infill, this is an infill density of 20%, and so you could increase that to 100%, so it would be a completely solid object, but it's going to drastically increase your print time. Of course, if you reduce the amount of infill, it will decrease your print time. And so I dropped it down to 10%, and we'll slice it again. And so you can see it dropped, what was it, about 50 minutes off of that. But you can see how much bigger of shapes this is inside here. So you don't have as tight of a infill. There are different infill patterns too, like you can do a grid or lines or whatever. Anytime you change a setting, you'll have to re-slice it. And so this is lines, so one layer it'll print lines this way, and the next layer it'll print lines this way. But you can drag down through each layer, see kind of what it's going to look like. And then also, get rid of this little warning here. Also, you can use this, and you can see the path that it's going to take for this particular layer. So here you can see it's going to start with the 1 foot. There's a little play button here. You can hit that, and it'll actually show you this is basically real-time speed of how fast it's going to print this layer. So it goes through, it prints one wall, and then it'll print this other wall. And we can kind of speed this up. Prints an inner wall, then an outer wall, and then it does the lines for the infill. And then it does the little support areas for where it needs to stack stuff up. So basically, that's it. Once you get your desired print time and your desired settings, you can save. You will need a micro SD card. And so this you could just save to a removable drive, and it's going to save it directly to whatever micro SD card you have inserted into your computer. So there we go, saved to a removable drive, and we can go ahead and eject our SD card so that we can put it into our printer. Before we do that though, let's look at one other thing that we'll need. So the other thing that you're going to want is a manual bed level process. When you slice the model using Cura, it creates what's called a GCODE file. And GCODE is just the instructions for the printer to know exactly where to move this extruder, how high to move it, everything it needs to do to print your file. For that to be successful, you need to make sure that the bed is perfectly level, because no matter where this extruder is on this bed, so whether it's in this corner or that corner back there or that corner back there, you want it to be the same distance from the bed. So there are some manual leveling processes. There's also some additional hardware that you can buy that will kind of do it for you, or calibrate it in software and kind of do everything. But the manual process isn't bad, especially with the help of a manual bed leveling file that you can download. So I'll give you guys a link for this. There's also a really good video showing how to do it, but I'll show you too. So there's a YouTube channel called CHEP, does a lot of 3D printing stuff, and he actually created a file to help manually level the bed on an Ender 3, and then also a print that you could verify that your bed was level. So I'll send you a link for that, but I'll just go ahead and put those files on the SD card and we'll get it moved over. Okay, so I got the little micro SD card, got the test dog, and the 2 bed leveling files on here. So with the label side up, right here in the bottom corner of the little control box here is a little slot for you to put this card in. Push it in and then push it all the way in, you should hear it click. The printer, we'll go ahead and power it on. And now we'll tap our wheel to get onto our menu, and we can go all the way down to the bottom and we'll see a print from media. So this is actually reading off of the SD card. You can see we've got 3 different files. There's the CHEP bed level print, and so that's the actual print to verify that the bed is level. The next one down is the CHEP M25 bed level, and so the M25 is needed because of the control board that is used in this printer. There's also a standard bed level G-code, but you need the M25 for this particular printer. And then you can see our test dog G-code file that we sliced. So I'm going to go down to the bed level and we'll click the button, and it says you want to start this print, and you can either cancel or print. Before you start this, you need just a small piece of regular paper, and this is going to be used to kind of gauge our distance. So we'll go ahead and hit print, and what this is going to do, it'll auto home so it knows where it's starting from. It'll do this before every single print. Goes and hits those limit switches, and you'll notice it says print paused here. So it's homed, it's ready to go. Now when we tap this button, it's going to tell it to go to the next spot. It's going to move this nozzle so that it's directly over the first leveling knob. Click into the menu and click resume print. And so it raises up, it goes over the leveling knob, and it pauses again. So now what you do with your paper is you want to try to slide it underneath the nozzle, between the nozzle and the bed. So I currently can't get this one in there, but there's a knob down here, and if you push the left side of the knob forward, that will raise the bed. If you push the right side of the knob forward, that will lower the bed. So I want to lower this so that I can get this paper under here just to show you. So I'm going to spin that like maybe a few small turns, and now you can see I can get that paper all the way through there. So now I'm going to left side of the knob, push it forward, and I'll test to see how close my paper is. I'll kind of drag it in and out. Go up a little bit more. Now I'm starting to feel it pull just a little bit. A little more. It's getting a little tighter. A little more. And so this basically I can't push it through, but I can pull it through. I'm going to go a little higher. So it kind of bends when I try to push it, but I can pull it through. So that's a pretty good spot to be. So I'll pull that all the way out. I'll go back in and resume print. It'll raise up a little bit. It'll go to the next knob. Now I'm going to go ahead and put my paper under there while it's going down. And so you can see this one is also adjusted. I can't push it through, but I can pull it through. I'll go to the next one, put my paper down. And so this one, you can see I'm going to push and pull that through. So this one needs to go up. So it's hard to get to the left side of the knob on this. So instead of pushing the right side, we're just going to pull the right side. It's spinning the knob the same way. Just keep going up very gradually until now I can pull it, but I can't push it. So that's probably a good spot. And now we'll go to our the next spot. So this one's way out again. So I'll raise it up. And then it'll go to the very center of the bed. And so this one is pretty good too. If you need to raise this at all, you have to do all four corners to get the whole bed to come up the same amount. So mine is good, but I'm happy with that. So go to the next one, and basically it goes around the same spots again. It's just verifying. It wants a second check just to make sure that adjusting one of the other corners didn't affect a different corner. And so if you never let the menu back out, all you got to do is tap. Oh, I didn't get it under there, but it's good. I'll do our last corner here. And that's it, we're good. So that is the bed leveling process. Our bed should be level and ready to print on. So now we will go to the actual bed level print. And so this is just going to verify that something will print successfully. So we'll print that, and you can see it's going to do its homing process. It does that before every print. And now you can see down here it says bed heating. And so you can see the bed is heating up to 50 degrees. Once the bed is finished heating, it will heat the nozzle up to whatever the set temperature is. I think it's 200. Okay, so our bed is up to temperature. The nozzle is getting really close. It's set to 205. We're at 200. So this should start here in just a second. So this print is going to be a series of squares, starting with a pretty big square on the outside, and it'll go around and do smaller and smaller squares just to make sure we have good adhesion on all parts of the bed. So it does a little beep to indicate that it's starting. is doing 2 lines down the very side here. That is just to purge the nozzle to get any like old filament out, get some fresh filament flowing through there. And now we can see it's starting to draw some lines on here. So this bed is warm, but if you rub over and this filament comes unstuck, what you can do is raise whatever corner that's in just a little bit. So this is going down pretty good. I can tell it's got some good squish, but it's not too much squish. And so I think we're dialed in and ready to start printing stuff. So transporting this, moving it from my house to your house, may cause this bed to get out of level. So you may have to do this again before you actually start printing on it. So it'll keep making squares until it gets to the very center, and then it will just repeat. And it makes these about 2 millimeters tall. I'm not going to do the whole thing, and I wouldn't recommend that you do it either. If the first layer sticks, usually it's going to be good. So there we got all the squares. It's going around, and it will start to do another layer, and it will just keep stacking layers up. This particular file will print these 2 millimeters tall, so that's just that high, but we're only 0.5 millimeter now, so it's about 5 or 6 different layers. But first couple layers stuck, or first layer stuck on all of the different sizes. So I'm going to go in here and we can just come down to stop print. And it asks us, are you sure you want to stop it? And so you can stop. So it's going to raise off the print and move over out of the way. So that's what happens when the print is aborted. So it moves the bed all the way back. Some of the settings, the start and end G-codes that I will send your mom, have it so it'll actually push the bed out here so you can get whatever you printed off the bed easier, so you don't have to reach over all this stuff. There's also a few commands in there where it'll play like a little jingle once it's finished. But that's basically it. This is the test dog that I started printing last night, and it was printing really well. You can see it's pretty good, but you can see the top of his head is missing. And so when I went away from the printer for a while, and when I came back, it was done printing. It had stopped printing, but it wasn't complete. So here you can see kind of what that infill looks like. It's just the cross-hatching inside, so it's partially hollow, but it's still strong. I can't actually squeeze it. I'll send this with you too, just so you can see it. But what happened is the spool of filament up there had a tangle in it, and it just kind of got a knot, and it couldn't pull any more filament out. And so basically it ran out of filament, and it kept on doing its thing until it got to the end of the file. There was no filament coming out. So that's why I have a headless dog, or brainless dog, I don't know. So one other thing that I forgot to mention, in regards to bed leveling. So this black surface on the top of here, this is actually a removable printing surface. So you've got your little clips in each corner. So it's a kind of a stiff piece of plastic, but it's got a little bit of texture, and it helps the filament stick to it. If you've got a print that is really stuck to this and you can't pry it off or anything, you can actually undo these clips, pull it off here, and flex this print surface, and it'll help get your print unstuck. When you do that, there is potential that you may have to re-level your bed. So if you're able to get prints off of it without removing this printing surface, that's the way to go about it. But you saw the leveling process. It's not that time consuming, and once you do it a couple times, it'll go super quick. And you probably won't even have to actually do the bed level print unless you're, really unsure if you have it level or not. So I think that's all I've got. 3D printing can be very, very frustrating at times, especially if things aren't working like you want them to. But this printer is really nice because there's a ton of community support on the internet. You can just type Ender 3 and whatever issue you're having, and usually find people that have had the same issue and know how to fix it. There will be issues that are unique to this that other printers don't have. There's also a lot of, on Thingiverse or Things, there's a lot of files that you can print to upgrade this machine to add different leveling knobs or things that will help guide your filament so that it doesn't get tangled or snagged on anything. So lots of stuff out there. Have fun with it. You can have your mom reach out and ask me questions if you're really stuck on something. And enjoy it. Happy birthday, dude.